Newton's second law of motion. Newton's second law of motion states the rate of change of momentum of a body is directly proportional to the next external force applied on it, and change in momentum is in the direction of a applied force. That means the rate of change of momentum is directly proportional to the applied force. The equation form of Newton's second law is F is equal to ma, where F is force and m is mass and a is acceleration. See the boy pushing the box with a force F. It has a mass m and which accelerates with acceleration a. So force is equal to mass into acceleration, that is equal to F is equal to ma. That means Newton's second law of motion states what amount of force we are applying on the body and in which direction we are applying the force on the body and what is the mass of the body. So body are all responsible for the body to move. That means momentum is directly proportional to the net force applied on the body and acceleration of the body. Okay, that means if the mass of the body is more, then the acceleration of the body will be less, because mass and acceleration are inversely proportional. That means if acceleration of the body is more, then the mass of the body is less. Okay, F is equal to ma, Newton's second law of motion. See, the car which is moving from T0 x0 to T1 x1. Here T is time, x is location, and m is mass, and v is velocity. That means first the car initially at in T0 x0 position, that at with velocity v0 and mass m0. T0 is the initial time and x0 is the initial location of the car. After some time the car moves to the next position x1 and t1 time with velocity v1 and mass m1. According to Newton's second law, force is directly proportional to the momentum of the object. That means force is equal to change in momentum with change of time. The difference form is equal to F is equal to m1, the final mass of the car and final velocity of the car, minus m0, the initial mass of the car and v0, initial velocity of the car, divides v1, sorry, t1. T1 means final time of the car, final time taken by the car, minus t0, initial time of the car with constant mass. If we take a car in this example, okay, if we take another body with constant mass, we derive Newton's second law as F is equal to, with constant mass can't change. That means m1 minus m0 is replaced by m. That means v1 final velocity minus v0 initial velocity divides t1 minus t0 final time minus initial time. That means rate of change of velocity. We already know that rate of change of velocity is called acceleration. So v1 minus v0 divided by t1 minus t0 is replaced by a. That means force is equal to mass into acceleration. We replace v1 minus v0 divided by t1 minus t0, that is change in velocity or rate of change of velocity is simply we called as acceleration with constant mass. So force is equal to mass into acceleration. This is the equation form of Newton's second law. Some common example for Newton's second law of motion are pushing a shopping cart. That means the girl in what amount of force and which direction she is pushing the cart. In that direction the cart moves or moments. Kicking a soccer ball, the girl, in which amount of force and which direction the girl kicking the soccer ball, the ball moves. Driving a car, the boy, in which direction the boy turns the steering and what amount of force, that means acceleration, he is giving, in that direction the car accelerates. Shooting a basketball, in which amount of force and in which direction the boy shooting the basketball, in that direction which accelerates. Launching of rocket, in what amount of thrust we given, on the basis of that the rocket moves, accelerates in that speed in opposite direction to the thrust. Swinging a golf ball, in which direction and what amount of force we are applying on the golf ball, on that amount the golf ball moves. Pulling a wagon, and in what amount and in which direction we are pulling a wagon, in that direction the wagon moves. Pushing a shopping cart or bicycle, in what amount of force we are applying on bicycle to uphill, in and in which direction we are applying force on bicycle, then in that direction the bicycle upheels or moves. These are some examples for Newton's second law of motion. We simply summarize as the rate of change of momentum is directly proportional to the applied force. That means what amount of force we are applying on the object and in which direction we are applying force, in that direction the object accelerates. That means force is directly proportional to the momentum and mass is inversely proportional to the acceleration. That means mass increases, acceleration decreases, or acceleration increases, mass decreases, because mass and acceleration are inversely proportional. Okay.